Keyword intro reveal Argus. On the morning of the 27th of August, 1958, a small United States Navy task force was holding station in the South Atlantic Ocean, roughly 1,800 kilometers southwest of Cape Town. The sea was empty in every direction. There was no land, no shipping lane, no friendly port within 2 days' steaming. At the center of the formation was a guided missile ship called USS Norton Sound. On her aft deck, secured against the swell, stood a 4-stage solid-fuel rocket designated X-17A. Inside the nose of the rocket was a 1 7/10 kiloton nuclear warhead. At 11 minutes past 2 in the morning, local time, the rocket left the deck. 3 minutes later, 480 kilometers above the Atlantic, well above the orbit of any satellite then operating, the warhead detonated. No one in the world outside a small list of names cleared for the operation knew it had happened. No press release was issued. No notification was sent to the United Nations, to the British government on whose nearby island territory radar would record the event, or to the Soviet Union, whose intercontinental missiles the test was designed to defeat. The detonation was the first of 3. Together they remain the highest altitude nuclear explosions ever conducted by the United States. The program was called Operation Argus. It was kept secret for 7 months, declassified piece by piece across the next 24 years, and its full technical report was not released until 1982. In October of 1957, the Soviet Union placed Sputnik 1 in orbit. 6 weeks later, a Greek-American physicist at the Lawrence Radiation Laboratory in Livermore, California, a man named Nicholas Christophilos, circulated a short paper to the United States Atomic Energy Commission. Christophilos was not a typical Livermore scientist. He had spent the war years in occupied Athens running a family elevator repair business, working out the equations of charged particle motion in his spare time on his own. In 1948, he sent a letter to the Berkeley Physics Department describing a method for confining accelerated particles using alternating magnetic gradients. The letter was filed and forgotten. 2 years later, when American physicists independently published the same idea under the name strong focusing, somebody at Berkeley remembered the envelope from Greece. Christophilos was invited to the United States. By 1956, he had a clearance at Livermore. The paper he circulated in late 1957 proposed something specific. If a nuclear weapon were detonated above the atmosphere, Christophilos argued, the fission electrons released by the explosion would be trapped in the Earth's magnetic field, exactly as the Van Allen belts had been observed to trap natural particles. Those trapped electrons would form an artificial radiation belt. Any object passing through that belt, a satellite, a re-entry vehicle, a Soviet intercontinental ballistic missile arcing toward North America, would be exposed to a lethal dose. It was, in effect, a proposal for the world's first anti-ballistic missile shield, made of nothing but charged particles and the planet's own magnetic geometry. The Christophilos paper landed at a politically useful moment. Sputnik had made the United States look slow. The Eisenhower administration was under pressure to demonstrate that American science was responding, and a treaty banning atmospheric nuclear testing was already being negotiated in Geneva. Whatever was going to be tested would have to be tested soon. In May of 1958, President Eisenhower signed off on Operation Argus. The authorization required 3 detonations in the South Atlantic at altitudes above 200 kilometers before the test moratorium took effect on the 31st of October. The Department of Defense gave the project to the Armed Forces Special Weapons Project, AFSWP, and to a newly created entity called Task Force 88. The task force commander was Rear Admiral Lloyd Mustin. He was given a guided missile cruiser, the USS Norton Sound, modified to launch ballistic rockets from her stern. He was given 8 escort ships, including the seaplane tender USS Albemarle and the destroyer USS Barris. He was given a launch window of 7 weeks. The launch site was chosen because of geomagnetic geometry, not geography. At 38 degrees 30 minutes south and 11 degrees 30 minutes west, the South Atlantic anomaly, the region where Earth's inner radiation belt dips lowest, passes within reach of a rocket launched from a ship. Nothing else about the location mattered. There was no land. There were no neighbors. There was no nation whose airspace in 1958 needed to be notified. The first launch was on the 27th of August. The X-17A rocket was a four-stage modification of a Lockheed re-entry test vehicle. It carried a single W-25 warhead, the same 1 7/10 kiloton device used in the Genie air-to-air missile, then standing alert with the United States Air Force. The W-25 was a small fission device by Cold War standards, at Argus altitudes that was deliberate. The point of the test was the magnetic envelope, not the blast. Argus I detonated at 480 kilometers. Argus II on the 30th of August at 490. Argus III on the 6th of September at 540. All three were observed. A satellite called Explorer 4, launched by the Army a month earlier and equipped specifically with radiation detectors, was already in orbit when Norton Sound put to sea. Its instruments were calibrated for exactly this experiment. So were a network of ground-based radar stations, 3 sounding rocket sites, 2 scientific aircraft flying out of Cape Town, and an Argentine geomagnetic observatory whose operators had not been told what they were observing. The data confirmed Christophilos's prediction. Each detonation produced a band of trapped electrons in the upper atmosphere, lasting for weeks. The artificial radiation belt was real. It was also, the data made clear, far weaker than the natural Van Allen belts. The fission yield required to produce a meaningful weapons effect, to actually disable a Soviet missile in flight, was enormously larger than the budget of any plausible test. Argus had proved the physics. It had also proved that the physics, in practice, would not produce a shield. For 7 months, nothing was said. The Eisenhower administration had hoped to release Argus on its own schedule, paired with a scientific paper at a moment of political convenience. The plan did not survive contact with the press. In March of 1959, a science correspondent at the New York Times named Walter Sullivan obtained a partial briefing on the test from a source inside the Department of Defense. He wrote it up. The Pentagon, faced with a confirmed leak, agreed to a controlled disclosure. On the 19th of March, the Atomic Energy Commission released a statement acknowledging that 3 nuclear devices had been detonated in space the previous summer. The statement was 4 paragraphs long. It described the test as of considerable scientific interest. It did not mention Christophilos. It did not mention missile defense. It did not mention the warhead yield. The technical report DNA 6039F, prepared by the Defense Nuclear Agency, would not be cleared for full public release for another 23 years. In the meantime, a treaty was signed. The Limited Test Ban Treaty of 1963 prohibited nuclear testing in the atmosphere, underwater, and in space. Argus, by accident, became the last American high-altitude nuclear test that would ever be conducted in a permissive legal environment. The Soviets, who had been running their own high-altitude tests in Kazakhstan since 1958 under a program called K-Project, would conduct their final exoatmospheric detonation in November of 1962. After that, every nation with a nuclear weapon agreed, on paper, not to detonate one above the sky again. The full Argus record came out in 2 stages. In 1982, the Defense Nuclear Agency declassified DNA 6039F, the Consolidated Technical Report. It is a 412-page document. It contains the trajectories, the yields, the observed electron densities, the names of the principal scientists, and an appendix of photographs taken by the launch crews on Norton Sound. Christophilos's original December 1957 proposal is reproduced as an annex. In 2001, the Lawrence Livermore National Laboratory published an official institutional history confirming Christophilos's role and crediting Argus as the laboratory's first major weapons physics demonstration. The Christophilos papers themselves, donated to Livermore after his death in 1972, were open to researchers in 2003. What the documents show, taken together, is that Argus did exactly what its designers said it would do, and that the answer it produced was the wrong answer for the question that had been asked. The shield did not work. In February of 2024, the chairman of the United States House Intelligence Committee made a brief and unusual public statement. He had, he said, become aware of a serious national security threat relating to a Russian capability under development. He declined to specify further. Over the following days, leaks from administration officials clarified that the capability in question was a nuclear weapon designed to be placed in Earth orbit, intended for use against the satellite constellations on which modern Western military and civilian communications now depend. The reporting was widely treated in 2024 as a new and frightening prospect. It was neither. The physics of the proposed Russian weapon, a nuclear detonation in orbit, producing an artificial radiation belt that would damage satellites passing through it for months or years, is the physics described by Nicholas Christophilos in his December 1957 memorandum. It is the physics that was tested in the South Atlantic by USS Norton Sound on the 27th of August, 1958. The conclusion Argus reached in 1958, that the effect is real, that the effect is broad, and that the effect cannot be confined to enemy hardware, is the conclusion that every analyst examining the 2024 reporting has independently reached again. The treaty signed in 1967 that prohibits the stationing of nuclear weapons in space is the only thing standing between the present and the President said, 66 years earlier, by a 4-paragraph press release from the Atomic Energy Commission. The Cold War is remembered as a contest of submarines, missiles, and silent codes. It produced all of those. It also produced, in the summer of 1958, 3 small fission devices fired 400 kilometers above an empty stretch of the South Atlantic, and a Greek-American physicist working from a desk in California who had calculated in advance precisely what the planet's magnetic field would do with the debris. The page they didn't want you to read was not, in this case, hidden. It was simply filed under the wrong heading for a long time in a building most people never knew existed. The file is open now,